Hi, my name is Stewart Lynch, and in this video we're going to build a customizable onboarding system that you can reuse in all of your apps. This system will be built using some of the new features introduced in SwiftUI version 2, which at the time of this video is still in beta just after the completion of WWDC 2020. To follow along, you'll need to be running Xcode version 12 or later, and as you'll see, I'm running the beta version. As we build this project, I'll introduce you to some new features of Xcode, iOS version 14, and SwiftUI version 2. These will include the ability to add SVG assets, the app storage property wrapper, which is a dedicated property wrapper for reading values from user defaults, the PageTabViewStyle, which converts a tab view into scrolling pages of content, improved previews and preview modifiers for your views, and a new global AccentColor asset. If this is something you want to learn, then keep watching. Before we dive into the code, let's take a look at what we're going to be building. Here is the completed application. When the app launches for the first time, after a short delay, the first screen gets blurred and disabled, and a set of onboarding screens are presented. You can swipe left or right with a scrolling page view, complete with the page index indicators showing you which screen you're on and how many there are in total. Both light and dark modes are supported. When you dismiss the onboarding screen, the app stores that you've done so on subsequent launches, the screen no longer appears. There's no starter project for this project, but there are resources that we can use to help us out. You can download these from the link in the description below. Let's create a new Xcode project in Xcode version 12. And from the iOS section, choose App and give your project a name. I'll call mine Onboarding and save it to my desktop. The first thing I'm going to do is add some images that I've prepared. And you can find these in the Starter Resources folder that you can download from the link in the description below. New in Xcode 12 is the ability to add SVG images. So let's open our Assets folder and drag these ones in. Now with them still selected, I'll choose Preserve Vector Data and choose Single Scale. Let's start by creating our main application view. This is simply an example. Your root view can be anything you like. I'll start off by adding in a VStack, and inside that VStack, I'll add one of my SVG images named Teamwork that I will make resizable and scale to fit. I'll also add some text, along with some horizontal padding, and I'm also going to ignore the bottom safe area. Next, I'll embed the VStack in a navigation view, and I have no idea why this isn't an option here, so I'll choose an HStack and then just change the name. And I'll add a navigation title of Onboarding Screens. Now we need to know when to present the onboarding screens, and for this I'll create a state variable called showOnboarding, and I'll set its initial value to false. I can now embed my entire VStack in a ZStack. Again, no option for that, so I'll just choose one of the other options and change it to ZStack. And within that ZStack, we can present another view on top of the existing one only if the showOnboarding is true. So, if showOnboarding, I'll create a placeholder for what will be my onboarding screens. I'll create a VStack, and within that, a rectangle with a frame width of 350 and height of 350, and a spacer that will push it up to the top of the view. If I change my default value for showOnboarding to true and resume our canvas, we get a feeling for what it's going to look like. Now I need to be able to store whether or not the user has seen the onboarding screens. And I'm going to store that state in user defaults. And for this, I'm going to use the new app storage property wrapper, which is a dedicated property wrapper for reading values from user defaults. All I need to do is specify my key as a string, like onboard been viewed, and assign my initial Boolean value of false to a variable that I'll call has onboarded. Now, anytime we change that value, it'll get stored to user defaults. We can use the view's onAppear function to check if we have not yet onboarded. And if not, we can toggle that show onboarding state value, which will show the onboarding screens, and then store has onboarded as true back to user defaults. Now, I don't want that to happen immediately, so I'll wrap it all in a dispatch queue.main.async after with a 2-second delay. Also, I don't want the appearance to just pop over, so I will do this with a default animation. We can test this now and see that it's working. Running a second time, we see that the onboarding no longer appears, which is what we'd expect. For testing purposes, however, let's temporarily reset our user default value back to false each time the view appears. Now, notice when our onboarding screens are visible, the background view is also clear. And if there were any controls there, they'd be active as well. So what we need to do is make that view inactive when show onboarding is true, and to set a blur value at the same time. So on that view, let's do that. Disabled first. Now let me check the library for a view modifier, and I'll drag it onto my view and set that blur to 3 if show onboarding, else 0. Testing now, we have the desired effect. Now we can start working on our onboarding screens. For this, let's create a new SwiftUI file titled Onboarding Screens. Now we know that we're going to have to dismiss the view somehow, so let's create a binding variable called isPresenting that will be bound to the show onboarding variable from our first screen. This creates an error in our preview, so let's fix that by setting our binding to a constant of true. We can return to our content view and cut out our VStack and replace the text view in the body with that. So what we want here is a paging tab view, which is new in SwiftUI 2. So let's embed this rectangle in our tab view first, and we'll repeat the rectangle 5 times by embedding it in a for each loop going from 0 to 4. Now to enable the paging tab view style, we add a modifier, tab view text style, with a page tab view style. Now the paging dots are white and translucent white. So if your view background is also white, you won't see them, and we can't. So to fix that, we can add another modifier that will place a background behind the dots. So indexViewStyle is equal to page index view style of a background display mode of always. We can now go back to the content view and replace what we cut out with our onboard screens and pass in our binding. Testing it now, we're getting there, but the rectangle is in the middle of the screen and the dots are at the bottom. Back in our onboard screens, we can fix that by setting a frame height that is the same as our rectangle. And this almost does what we want, except that the indicator dots are on top of our rectangle, and I want them below. So I find that if I add 120 onto the height, that works well. Here's an image of what we want to have our onboard screen look like. There's a title with a close button on the right, along with an image in the middle, and some description text below. We'll need to create a data model for that. So let's create a new Swift file called onboard card, and within there, create a struct of the same name that will conform to the identifiable protocol so we can use a for each loop. We'll create 4 let properties: ID, which is a UUID, a title of type string, an image for which we will provide the string name of our image in our asset catalog, and text, which is also a string. Now we also need to create our view model that will provide us with an array of these onboard cards, along with our desired dimensions. So let's create another Swift file called onboardSet. We can create a class of that name and start by creating a var named cards that is initialized as an empty array of onboard card. Next, we'll create 2 CG-float variables for width and height and initialize them with a default value that I think is good on most screens, which is 350. And since we're using a CG-float, we need to change our import here to UIKit. Now I'm going to follow best practice and change these variables to private set, and then create a function that will allow me to modify these values by way of an instance function. So the function for changing our dimensions I'll call dimensions, and it'll have 2 arguments, one for width and one for height. And I'll just assign those values to our private variables. The function for appending values to our card array will have 3 parameters: a title, an image name, and text, all strings. And the body will just append a new instance of an onboard card using these 3 values. Now we're going to want to have some sample data that we can use when we are building our card view. And for this, I'll create an extension on the onboard set, and within there, I'll create a static function called previewSet that returns an instance of onboard set. In the body, we can create our onboard set instance. And then we can just call the newCard function on this instance to append new items. For example, onboardSet.newCard with a title of login, an image name login, and some text like this. Now to speed things up, in your starter resources, I provided you with text for 5 cards in total. So let's just copy that, and I'll paste it in here to create these cards. And then finally, we need to return our onboard set. Okay, now we can build our card view. Let's start by creating a new SwiftUI file that we'll call OBCardView. And we'll replace the rectangle in the onboarding screens with this. In order to build and display the card, we're going to have to know a number of things. First, we'll have to have some way of dismissing this card, and it will be bound to the original showOnboardingState variable in our content view that was passed on to our onboarding screens view, which has to be passed into here. So let's create a binding called isShowing. This card will receive 3 values from the onboarding screen, one for the current card, another for the width, one for height, so we can create 3 let constants for those. And this creates an error in our preview, so we can use our preview model to fix that by using our preview set. So in our OBCardView previews, we'll create a static property, let onboardSet equals onboardSet.previewSet, and for our OBCardView, we can pick one of those and specify a width and height for a preview. Now we can build our card, and we'll start with a VStack that contains our three main sections. Let's start with a title, and we'll make it a large title. Then our image uses the string card.image, which we will have to make resizable and scale to fit. We can add our card text and then use a spacer to push it all up to the top. For our button, we'll embed the title in an H stack and add a spacer and a button that's a system SF image of xmark.circle.fill, and we'll scale it to the size of a title font. For the action, we'll animate the setting of our isShowing to false to pass back the bound state variable in our content view to hide our onboarding screens. Let's add some horizontal and top padding to the entire VStack. Next, we'll add a frame to the VStack using the width and height that we received. And then finally, we'll use a background to the VStack that has a corner radius of 10, that's continuous, with a secondary system background fill and a shadow radius of 10. Now this is looking really good, but there's no reason why we are showing the entire iPhone here when all we need to see is the view. So we'll choose the Preview Inspect Preview and choose Preview Layout, Size that Fits. Let's add another preview, and notice that it adds the code for us in our preview code. And this is new in this version of Xcode. And let's change that preferred color scheme to dark. And while we're at it, let's change the width and height to 400 by 500. And I'll pick a different card. It's looking good so far, so we're getting there. Now we can return to our onboarding screens. First, let's create a new variable that will receive our onboard set from the content view. Now we haven't done that yet, but we will in just a minute. And we can fix our preview by adding in this argument here. Next, we'll replace our for each loop by passing in our identifiable onboard set instead of our rectangle. We'll ask for an instance of the OB card view, passing in our binding, the card item in the loop, along with the sets, width, and height. And there's no need for this frame here as we set that in our OB card view itself. We do need to set the frame height as it can be variable. So let's replace the 350 with the onboardSet.height. Now returning to Content View, as we need to create an instance of the onboard set. Remember, it was an empty array of cards, so we'll have to fix that shortly. So var onboard set is equal to onboard set. And we can now pass this on to the onboarding screens. So if we return to onboarding screens now, our screen should be displaying properly. We have everything we need now except the data for our cards. We have our preview set, but that was used just for our preview. We can create an entirely unique set of cards for whatever our application needs. Now, one way to do this is in the onAppear just after we check the status of whether or not we've viewed our onboarding screens. To save some time, rather than creating a different set, I'm just going to use our preview set. So let me just copy it from our extension and pass it in here. Let's test. All right, it works. but there's lots of data here that really doesn't belong in our content view. Now we could just use our preview set by removing this content here, and at the instantiation of our onboard set, we'll just assign the preview set. See, same result. The trouble is, if we want to create a reusable package for this onboarding set, we can't package up our preview set as it will change for each application, and it's an extension of the onboard set. So let's create a new file that we'll call onboard data that will be unique to this application. The rest of our onboard files can be used in any application. Now within that file, we'll create an enum that we'll use as a namespace to contain a static function. I'll create that function called buildSet that will accept a width and height but default to the values that are the defaults of our project and return an onboard set. We'll need to import UIKit as we're using a CG float here. Now we can use this for any project to create a new onboard set and set the dimensions to whatever is passed in. So let onboard set equals onboard set, and we'll need to return this set. But before we do that, we can use the dimensions function to change the dimensions in case I want to do that. And I'll show you that in a minute. And in between, we can create each screen's cards with the new function. And again, for the sake of time, let me just use the same data that we have in our preview set. But I hope you see that this can be whatever you want because we're outside of our onboard files. Now finally, we can go back to our initialization and call onboarddata.buildSet function to obtain our onboard set. Testing again shows that it's all still working. Now we haven't tested out the dimensions yet, but we can do that easily by changing the defaults by passing in a different width and height. Now this is pretty cool because we could potentially pass in conditional width and height based on our device and window sizes. Now there's one more thing that I want to do. I didn't like that blue close button. It is using the application's global accent color, which doesn't really match the color of my images. Well, in Xcode 12 and iOS 14, there's a new item in the asset catalog that's called AccentColor. And I can change that here. So let's choose an sRGB and set the RGB values to 0, 138, and 21. A nice green to match our images. Running this one more time, I see my close button is now green. I have a problem with this though. I don't like when the title is over 2 lines, how the button is no longer at the top. Well, we can fix this by going back to our card view and setting the alignment of our H stack to top. One final run shows me that I'm done for now. I hope you've enjoyed building this project and that you can use this in your future applications that use iOS 14. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.